Recent security audits of the Anthropic ecosystem have uncovered a pair of severe liabilities: undocumented browser bridges quietly placed on your machine, and deep architectural flaws within the Model Context Protocol itself. Left unpatched, these vulnerabilities expose your system to remote command execution, unauthorized access to authenticated browser sessions, and ultimately, complete system takeover. To fix this, we are going to walk through a 4-step process to audit your machine, strip out the backdoor, and completely sandbox your AI environment. Before we begin, look at this checklist. You will need a macOS machine, access to your terminal, and a basic familiarity with local sandboxing tools like Docker. Because the vendor currently classifies these behaviors as expected design choices, nobody is going to push a magic security patch to your machine. Securing your sensitive data requires taking manual ownership of your local setup. Step 1 is removing the silent browser bridge. When you install the Claude desktop Mac app, it silently places a native messaging manifest onto your system. This file intentionally circumvents standard browser sandboxes to establish a backdoor for browser extensions you might not even have installed. To find out if your machine is compromised, open your Mac OS terminal so we can run a system audit. Run this find command targeting your application support directory for com.anthropic.claude.browser extension. In the output, carefully target the undocumented file highlighted in red. Do not confuse this with the official Claude Code CLI bridge. Once you have located these specific spyware manifests, execute a delete command to remove them from your browser directories. But simply deleting the file once will not solve the problem. The Claude desktop app is programmed to actively rewrite this exact backdoor every single time the application launches. To implement a permanent mitigation, you have 2 options: either uninstall the desktop application entirely, or change the permissions on those target native messaging directories to read-only, so the app can no longer write to them. Permanently neutralizing this manifest closes a massive vulnerability gap. It ensures that a malicious web-based prompt injection cannot escape your browser to execute arbitrary code directly on your host operating system. Step 2 focuses on the systemic flaw within the Model Context Protocol, or MCP. The standard MCP architecture allows AI agents direct access to system and shell execution by default. This split screen illustrates the risk. On the left, vulnerable raw input flows straight into an exposed system shell. On the right, that same input hits a Docker sandbox barrier, actively blocking the agent from reaching local disk drives or databases. If your configuration relies on standard I/O server parameters, there is a strict rule you must follow. Public IP access to these services must be completely blocked. Furthermore, to prevent arbitrary command execution, you need to hard code your allowed commands. Never pass external user input directly into your downstream MCP configurations. While sandboxing cannot fix the underlying protocol design of MCP, it successfully traps any remote command execution within a disposable, harmless container. Step 3 addresses the supply chain. Popular AI IDEs are heavily reliant on third-party MCP registries, making them prime targets for poisoned updates. To understand the scale of this threat, security researchers recently proved they could successfully compromise 9 out of the 11 public MCP registries available. Take a look at this configuration panel. You need to audit your package managers and ensure your agents are configured to pull exclusively from verified sources. Lock your settings to the official GitHub MCP registry, shown here, and block unverified third-party URLs. Step 4 is establishing continuous monitoring for your AI tool invocations. You need to watch your logs for specific anomalies. Watch for background tools activating without a direct prompt from you, or attempts to exfiltrate data. As shown in this network flow diagram, the best defense is setting up strict IP and URL blocking at the firewall level. This allows your system to instantly intercept and destroy any unauthorized outgoing data request before it ever reaches the public internet. By tightly controlling your supply chain and strictly monitoring outbound traffic, you ensure that even if an agent is somehow compromised, it is starved of malicious updates and entirely cut off from the outside world. By completing these 4 steps, you have successfully closed the undocumented backdoors and insulated your local machine against external control. While millions of unpatched default installations sit in the wild, completely exposed, your local environment is now a hardened, isolated fortress. When major AI vendors ship tools with severe architectural flaws and categorize vulnerabilities as expected behavior, the burden of security falls entirely on you, the individual developer. Maintain your sandboxes, stay vigilant with your updates, and treat AI agents as untrusted.